Right. Command line interface. See, when we turn on the router, I'll show you how the router will look like. Yeah, this is how the routers will look like. And to show you this. So now if you see this one, very nice. Actually, this one has got a blue label. You see, here it is written console. Alright, the graphics is not that clear, but it's big. I'm very happy it's big. Now, this is written here console, and here it is written auxiliary. X. Now, this is what F00. This is F01, F02, F03. This one is F1/0, 1, F1/1, F1/2, F1/3, which means this is the 0th slot, this is the first slot. In the 0th slot, this is 0th port, this one, 0th port. In the 0th slot, it is first port. This is how they are named. Now, this interface, these ports are meant for communication. Our data goes inside this port, they come out on another port. Whereas this console port is only for console, is only for managing this device. It's meant for managing this device. In olden days, to manage, we were also using this port called auxiliary port. Auxiliary port is when you have a dialer, like a phone dialer, like a phone, olden days phone had dialers. Such, network, dialer network, olden type. We used to connect the wire and dial and log in. That is what auxiliary port means. But nowadays we don't need this. We don't use this. And this is how. This is the port via which you are able to see inside of the router. If you want to configure, in Packet Tracer, we just double clicked. We just clicked like this, and you got this command, like this one, this page. But in real world, how do you do that? In real world, this is how the router will look like. They don't have any monitor, they don't have any mouse, keyboard, nothing. Then how do you configure this? We will connect our laptop or computer to this console port using a console cable. There is a special cable called console cable. Let me show you that. Console cables will be blue color like this, but they are not too long. Maximum of 2 meters you will find. You see here, this end is what we connect to our computer. This end, this is what RJ45 jack. You see here it is written RJ45 console cable. This is what this port, this connector is what called as RJ45 connector. Registered jack 45. That is how the name is given. Registered jack. Now this is what goes here. There it is. In this place. This pin. This jack is what we connect. You see here they show this. Like this. Yeah. So this end connects to the box inside here. And this end there will be 9 holes inside this. 9 hole. We call this as D9 connector. D9. D9 connector connects to the computer, our computer, to a port called COM port. COM port, communication port. So one end is D9 connector, another end is RJ45. This is how it is connected back to back, using a console cable. So we connect the wire and then we start the router. There will be a power switch. See, this is the power plug where you plug in the power card. All right. So there is no front side of the router here shown, but the front side will have a power switch. See here, the console port is separately kept. Let me show you the front side of the router. No, right in the back only. Usually the switches come, but for some device it may be in the front. You see, here's the power switch. I'll open in another big screen. Yeah, this is neat. See, That's a power switch. And there's a power socket where you connect your power slot. There's a power port where you connect the power cable. And this is the switch, power switch. And you see it has got two interfaces. This is gig Ethernet, GE01, GE00, not F. In our here, when we try connecting, we see F means fast Ethernet. Here it is gig Ethernet, GE01, GE00. You see console port, console written, it is written console, console, and here AUX, AUX. So when we on this, after connecting, let me do that. This is your laptop, this is your computer, and I told you the console cable will be blue. You see this is blue wire. I'm connecting to RS232 to console port. Now, when you go here and click on desktop and click on the terminal, this is default, just leave it okay. Now you see the router. It's asking yes or no, we type no, and then we start configuring. But this is actually, in the real world, this is how we do. But in Packet Tracer, you don't need to do that. Simply just click on the router, it comes like this. But in the real world, we need to connect a console PC. Let me repeat again. In the real world, we have a computer. Only with the help of a computer, you can see and configure the operating system of the router. Because the router don't have any monitor or keyboard, you need to connect. For that, the wire is console wire, special wire, which goes with D9 connector. The other name is RS232, D9 connector. And then connect the control port of the router. I just showed you the console port of the router. And then go here to your computer, and in your computer you have a software called PuTTY. In the real world you have a software called PuTTY, but here you just click on terminal, say OK, and then you will see a router. Now done. Now I want to show you the software in our laptop that we use to log into that router. This is what it is called as PUTTY, PuTTY, whatever. This is the one. This is the one. So after connecting my laptop to the router, I need to click on serial. You see, COM port. In my laptop, I told you, in my laptop, it will be connecting to the COM port. Which one? Router will be connecting to the COM port. You see, I wrote here COM port. On my computer. COM port. So you choose COM port here, and you see same 9600 which you saw in the Packet Tracer simulator. When I connected, see 9600. It's the same thing my device is showing here, This is original. This is real laptop. This is real laptop I'm showing. But this one is simulator. You say okay, right? Likewise, here also you need to say open. When you say open, you will start seeing the router. Same like what you saw here. Same like this, you'll start seeing router. Please ask me any question if you have. Please, do you have any question? I can make it more clear if you want. If you have question. Okay, great. So we got the control. We got the access to the command line interface. So whenever you on the router will automatically load. And if you see that, I would like to show you. Whenever we on the router, say for example, I off it now. You see here also I can off it in your simulator. See we are connected to the console port. Now you just off it, off the router. Now if you go, it won't allow. Device must be powered on. Okay, I'll power on. And now if you see it is doing something here. Read only, ROM initialized. Now self decompression. Wait. So this all happened automatically as soon as I turn on. Self decompressing the image. What is image? The operating system is what called as image here. The operating system is saved in an image format. So these things and all, this things comes in the screen automatic. And if you see here, it says there are two fast Ethernet interfaces. There are 2 ports only in this router. And it is also showing you how much of memory it has got in total, how much is left, and how much of NVRAM, non-volatile random access memory, NVRAM. The size is 191 kilobytes. Flash, non-volatile. Let me write it down here. Volatile means it get erased. Whatever is written inside get erased when the power goes off. That is volatile. Non-volatile means even if the power goes down, all that you have saved will be safe. For example, all the pictures that we have in our cell phone, even if the power goes down completely, they're still there in your cell phone, even if the power goes down completely and there is no power. But the pictures that you took when we had power is still there. So when you recharge the batteries of your cell phone and reload the cell phone, you can see the pictures because the memory is non-volatile. Okay, say for example, now I have written this non-volatile and I did not save this file. In this moment, if the power goes off from my laptop, I lose whatever I have written because I have not saved it to a non-volatile memory. I have not put it in my hard disk. Right now, this is not in a hard disk. It is just coming from a temporary memory. Whatever I write here. Hi. But this is not really saved anywhere. This is just temporarily kept in a volatile memory. Volatile memory. Erasable memory. So when the power goes off, all this will go away because we have not saved it. What is the meaning of saving it? Pushing the data into a non-volatile hard disk. In computers, you call it as hard disk. When we say I'm saving my file, what it means is I'm pushing the data to a non-volatile location, non-volatile memory, hard disk. Whereas when we say non-volatile memory in router, it means a small chip. And in this router, the size of the chip is 191K kilobytes. So this is where all that you configure will be pushed if you say save. Now, if I want to start from the beginning, the router I just turned on, and I saw a lot of things going on without my control, lot of things. And then here it comes and stops. Actually, what it is. See, as soon as we turn on, the control goes to a memory called flash. Flash memory. Now, this is the memory where our image is kept. You see here? Go top. It is said that the bootstrap version, meaning there's a small operating system which will start this big operating system. There's a small operating system in a location called ROM, read-only memory. From there, it locates the, ROM. From there, it locates the location of image in the flash, where the flash is what containing this image, the operating system. The operating system is what here we call as image. The image, the operating system is kept in a flash memory in a form of image. The operating system is kept in the flash memory in the form of image. Now that get decompressed. Look at this. Somewhere you should see flash, you see? Flash. The flash memory size is 63488. See, this need not to be same on every router. Even in the packet tracer, your packet tracer may show different number. But because the version of the router matters. My simulator run simulates the version called 1841. Now if I take another one, 1941, there's 1941, it may be different. The flash memory may be different. See, it's decompressing. The operating system is getting decompressed. What does that mean? Okay, you see, here the non-volatile is bigger one, bigger than the previous one, and the flash is also big size compared to the other one. Here it is, flash is 63, just 5-digit number, but here it is 6-digit number. T498556K. Even the NVRAM is 191. Here, the non-volatile is 255K. Big size. This has got 2 gig Ethernet, but in that router we have 2 fast Ethernet. So you see, right on the beginning, very first page, you see all this information. Now, from where this is coming, as soon as you turn on, the router will locate the flash memory with the help of a small operating system which is stored in read-only memory. And that operating system leads the control to the flash where the big operating system, the iOS, Cisco's operating system is called as iOS, Internet Operating System. So this Internet Operating System is a single file, and the file format is image. Now that single file need to get extracted into multiple files. That is how operating system comes. So that single file, image format file, gets extracted. That's what it was showing as decompression. It is getting extracted, decompressing, meaning it is in an image format, compressed format. Now it is getting decompressed. That's why it shows like this, getting decompressed. Decompressed file will be big than the compressed file. Correct? No, see the pillow. Some pillows when we buy in shop, it will be like a very thin paper, But as soon as you remove the plastic cover, it becomes a pillow. Why? Because initially it was in a compressed format, pressed down very well with some machine, and they put the cover and they roll it and give you like a paper. The pillow comes like a paper. And as soon as you uncover that plastic, the air goes in, and the air from the atmosphere is making it to bulge like this, a pillow, to rest our head. Likewise, the operating system called iOS is compressed and kept inside this flash memory as a single file. It is kept. Now, as soon as you turn on the router, this image will be there, but a copy of that image will get decompressed. Repeating again, the image will be still there. That will never get disturbed. That will not get altered. Just a copy of that image is getting decompressed. And it is getting decompressed into a memory called DRAM, dynamic RAM, dynamic random access memory. This one we saw non-volatile, NVRAM. This is DRAM. The operating system gets decompressed into DRAM. You can see DRAM size. This is DRAM. Sorry, here. DRAM configuration is 64-bit. So it gets decompressed. See, the original operating system is not disturbed. A copy is taken and decompressed into DRAM. So what you see here is DRAM. DRAM is what's showing you all this. And if I give some name, host name, route, it's already named as a router. I'm going to change the name. Let's say Heaven. I change the name to Heaven. Where is this saved? It is saved to a temporary memory called DRAM. DRAM. From there only it shows this is a volatile one. This is volatile. See, if I don't save it, see, I'm going to switch off. Off. I offed it. Now when I on it, again it is decompressing and nothing will be there. I gave a name called Heaven, but nothing is saved. That's why it is asking, do you want to configure? If it is saved, it won't ask you this question. You see, it's still router only. But if I want to permanently save it, I need to say Heaven, host name is Heaven, and I need to save it. Copy, run, start. You know what is the meaning of this? Run means, running configuration means all that is there in the DRAM. That is the meaning of running configuration. Whatever you type is what running configuration. They are all saved in DRAM. I'm saying copy all that you have in the DRAM into NVRAM, which is called a startup config. This is running. You see, I am saying copy all that is there in the running to the startup. Now if you go and off the router and on it, you see it will not ask you that usual question, would you like to configure using dialog? It won't ask this time. It will not ask you. You see, it's not asking me. I press enter and I can see Heaven is the wonderful place. Heaven. Which means whatever I configured, I already saved it. So from there it is fetching it. When you switch off the router and on it, when you switch off the router and on it, it goes and loads the operating system. On the way, it goes to NVRAM, fetches the Heaven and brings it and puts it into DRAM. That is why it is called a startup config, startup memory, because when you start, it goes and see whether any old configuration is available and loads all of them into the DRAM along with the operating system. Now, whatever you configure will be temporarily kept in DRAM, but only when you save, it is moving, a copy is moved to NVRAM. You need to save it. Only then the copy is moved to NVRAM from DRAM. So we have seen here three different type of memory locations. One, the flash. The operating system is kept in the flash. The operating system name in we call it as iOS. In Cisco, the operating system is not called as Windows. It is not called as Linux. It is called as iOS, Internet Operating System. Internet. Internet Operating System. And now the operating system gets loaded and you turn on, it gets loaded. But on the way, while loading, it will go to NVRAM, check whether any configuration is already saved here in this router. If it is empty, only then it will ask you this question. If the operating system is empty, then only it will ask you, sorry, if the NVRAM is empty, only then it will ask you this question. If it is not empty, for example, we already saved something called heaven. So here, when I on and off, it never asks me that question. So if NVRAM is empty, it is going to ask you, would you like to configure? See, it's not asking me any question here. So it goes to NVRAM on the way and checks whether something is there. If something is there, it comes and loads to DRAM along with the operating system. If not, if this is empty, if NVRAM is empty, then it is going to load only the operating system to DRAM, and you will be asked that question: do you want to configure dialog yes or no? Now, what is that? Do you want to configure dialog yes or no means? It means that there is no configuration seen in NVRAM. Would you like to use a dialog method, meaning router will ask a question, you will answer. For that, you no need to know commands. See, if someone bought a router, spending a lot of money, and if he don't know how to configure it, then he won't be happy. So for them, for a non-technical guy, there is an option. He should say yes here instead of no. We will say no, but a non-technical guy will say yes. Why? Because he don't know commands to configure. To help him configure, see, it is asking, would you like to enter the basic management setup? Yes, sir. Okay, what is the name that you want to give to this router? Currently, this is the name. Then he will type heaven. Okay, sir. Do you want to put the password? Enable secret password. Even if I don't like to give password, it won't allow me to see the next question until I put the password. I say, okay, put this password Cisco 123. Do you want to put the enable password? Yes, sir. What is the password? 123. Do you want to enter the virtual terminal password? See, these things are not necessary for me, but if I don't give this thing, I will not be able to put any IP address on the interface. That's why we don't say yes to this. We always say no. Because we know commands, we will go straight to what we want and we'll configure it. We can go straight to the interface and we can put IP address. But in dialog mode, that is not possible. You have to answer a lot of questions to come here. Okay. So we say no always in that mode. All right. So